So a long time ago, I was watching Tango Tech's Better Villagers mod and thought, I bet I could make this better. So obviously you'd think I'd start by forking his code or starting my own Minecraft mod, but I began by starting a new game project in Unity. Making Minecraft because I'm stupid. Okay, so a good place to start seems to be this video by Sebastian Log. Let me pretend like I'm smart by copying his code.
We have a map with a width of 9. In other words, we have a set of maximum possible height 0 to h. So in our 4 points, use that will take any action for now and to update h. So in the exercise writing down further, we request this time
This seems to be something. I also added some Poisson disc sample trees, but they're kind of lagging out the game. Also, these textures are layered like a cake you'd find at a 5th grade birthday party. Anyways, I want to add some biomes, so let's do that real quick. That's looking pretty neat. They're kind of blocky because they're being applied on the chunk level, but otherwise I'd say it's a pretty nice improvement. Now there's these huge cliffs between adjacent chunks, so let's try to smooth these out. Basically, I allow each chunk to detect its neighbor's biome, and if the height map is close enough to the edge, it'll blend between both heights. I also added some nav mesh animals and water and whatever this is. We don't talk about this. Next, I guess it's time to add some caves. So because I'm just using a 2D height map, I can't exactly make caves. Luckily, Sebastian has this other video on Russian cubes, and he also mentioned he boosted performance by writing it in a compute shader. So let's try to do that. Now that I have a new computer, I got it working and now we have these long globular shapes, which I think would look good as canyons or caves. Anyways, let's see how many of these we can generate.
Nice.
Alright, but it is kind of slow moving around, and I think one reason for this is because a lot of geometry is duplicated between the voxels. I can try to read back and eliminate this with a hash table, but
what is that? What the fuck is that?
Luckily, this guy on Reddit suggested we do something cool, so I did the cool thing and now it's a lot faster. Okay, but in all fairness, that technique is pretty cool, so you should all check it out. Now I want to make a surface to this world, so let's try to generate a height map and cut off these blobs at that height.
A man has fallen into the river in Lego City.
This seems to be an issue because the geometry of the surface
even though
is defined by geometry maintains the scale and types of caves. This is by having a sound noise map allows you to create different part of the geometry that's not based on very.
Nobody cares!
Alright, these two lines here are the blob caves, and I combine it with our Lego surface with a squash factor, which is also controlled by a noise map. This line controls how thick the atmosphere is. Now our ground is smooth. On the other hand, we also have this to deal with. It's not a bug, it's a feature. Actually, the other day I saw this video on Minecraft terrain generation where they use a squash map, so I guess this parameter is kind of the same idea. You might have also been wondering how I have these splotchy textures. Well, I just looped through a list of materials for every voxel. Each one distorts the same noise maps with their own unique factors, and I just take the local maximum of these distortions. I want to add biomes back, but I don't miss those cliffs. Luckily, that video I watched suggested a cool idea. Rather than the biome dictating terrain generation, what if we choose the biome based on the type of terrain generating? So the terrain generation is controlled by these noise maps, whose values are interpolated based on these curves. We can say if the value falls between this range and all these noise maps, then it's a desert. These ranges represent the side length of an n-dimensional parallelepiped, or more dimensions. We can see this phenomenon represents the solution based on the biome of the domain of our representation allows us to very clearly look at range changes, look at the rectangles
Oh, brother, this guy stinks!
Anyways, we have all these cool biomes now. I also added water, structures, and a rain-marked atmosphere, but that's for another video. In all seriousness, I want to make the world much bigger, but... So let's try to add levels of detail to our mesh. Huh? I guess we have more chunks, but we also have these weird fractures between chunks. Also, if we push it too far, we get this. Thankfully, I came across this way of organizing chunks. Unlike my current strategy, using an Octree will reduce my chunk overhead as well as allowing me to scale to ridiculous sizes. Also, this doesn't seem that hard to do.
Many months later.
Why do I always say these things? Anyways, I got it working. These colored outlines represent chunks, and as the game runs, each chunk is updated and auto-corrects itself by either merging with its neighbors or subdividing itself. Also, we can change the balance factor of this tree. Now let's apply this to the terrain, and...
What? What the fuck?
Okay, I fixed the offset and scaling, so let's see how big we can make it. I also moved all the generation logic to run on computers because I'm a masochist. Now let's try to fix these cracks in the terrain. According to this paper by Eric Langell, I can use some complex voodoo voxels to blend between these two detail levels. It's just like programming marching cubes in a computator, but twice as long and 10 times as cancerous.
Warning, do not write code like this. Magic numbers and magic matrices can cause confusion, disorientation, lack of sleep, general loss of vision, depression, self-doubt amongst other symptoms. Please see your doctor for more details.
Also, because our Octree may not be 1 to 2 balanced, we have to layer multiple transition layers on top of each other. And before you go,
Oh, you should use surface nets.
yes, I'm aware of surface nets. I chose not to use them because it's difficult to assign consistent materials to its surface like marching cubes. You're not smart. Can I complain about something? This Eric Langell in all his wisdom wrote his lookup tables with a different ordering than his paper describes. Instead of this ordering he claims to use, the LUT encoding uses an Archimedean spiral that he doesn't document anywhere. Like, am I supposed to know that you did this just by looking at these magic numbers? On another note, because to solve these voxels, each chunk needs information about its neighbors, all the chunks are stored in a big GPU buffer that uses a malloc program that I wrote. In other words, this is the amount of CPU terrain generation code now, this is the amount of CPU code minus the instructions for dispatching GPU code, and this is the amount of GPU generation code. What this means is our generation is super fast. On the other hand, I am definitely not going to regret this. By the way, I got tired of listing the same underground materials under every biome, so I made 3D biomes, which saves us a lot of repetition. These sky biomes control mostly cloud shapes, and we can also make storm fronts and tornadoes. The terrain still looks round and uninteresting, so I found this talk from the developers of No Man's Sky where they mentioned erosion and domain warping. I remember Sebastian had a video on erosion. Let's see if it can be of any help.
Just as a very rough reference, this is a 255 by 255 map, and it took roughly 3/4 of a second to run.
Yeah, nope. But we can cheat by using some gradient-based erosion. In essence, we smooth out a slope by how steep we observe it to be. To do this, when we loop through all the octaves, we can scale down each octave by this factor, which is accumulated from this function, which finds the analytical derivative of each octave. Finally, we can add this function to add some domain warping. The intensity of this is also controlled by 2 noise maps. Alright, finally, let's see what we get. So yeah, that took way too long. But I guess on the bright side, I can finally take a rest. Wait!